Hello everyone, I am SAIKRISHNA from MLJT College of Engineering, pursuing my MTech in Computer Science and Engineering. The paper is titled An Invisible Logo Watermarking Based on Texturization. My co-author is Ms. Reshmipriya NG. She is my guide and she is working as Assistant Professor in MLJT College of Engineering. Any queries or clarifications regarding this paper or the presentation can be sent through the mail ID which is given nsaikrisHna92@gmail.com. Initially, I will be explaining about the introduction part, which includes the basic concepts or the techniques regarding the proposed system, and then about the summary of the related works or papers regarding this proposed system, and later moving towards the proposed work in detail and its final findings and analysis, and finally ends with the conclusion. For the protection of the copyright information, to embedding the hidden information into the digital content is called the digital watermarking. The digital content can be any text, image, audio or video file. This is used to identify the ownership of the copyright of such files. This is the general block diagram of watermarking. Initially, we will be having the watermark and then the original image as the input to the watermarking algorithm, and then we will be obtaining the watermarked image. Main properties of watermark include robustness, imperceptibility, capacity, and then security. In the case of robustness, the watermarking algorithm should be robust to tolerate different forms of attacks or image processing operations when watermarked image is being transmitted. Watermarked images and the original images need to be identical. That proves the property of imperceptibility. In the case of robustness, we will be having certain attacks, which is geometrical attacks and also non-geometric attacks. So, for example, in the case of geometric attacks, we have translation, rotation and scaling. In case of non-geometric attacks, we will be having noise like Gaussian noise, or in case of salt and pepper noise, shear noise, etc. In the case of capacity, which refers to the maximum amount of watermark bits that can be embedded into the original image. Moving towards security, an unauthorized person cannot detect or retrieve or modify the watermark, or it ensures that the watermark is completely embedded within the host image. And this complete means of embedding can be done through cryptographical manipulations or certain kind of encryptions, or we can do those kind of encryption through dynamic mapping, or say for example logistic mapping, and also certain transformations like Arnold transformations. So the watermark is being classified based on human perception, robustness and the type of document, and according to human perception it is being classified into invisible watermark and visible watermark. Here you can see the visible watermark and invisible watermark. According to robustness, the watermark is being classified into fragile, semi-fragile and robust. In the case of fragile watermark, it is failed to detect the watermark after slightest modification. In the case of semi-fragile watermark, it fails to detect the malignant transformation event. In the case of robustness or robust watermark, it is resistant against designated class of transformations or resistant against hostile or user-dependent changes. And based on the type of document, it is being classified into text, image, audio or video. So moving on to the techniques of watermark embedding, it is being classified into simple watermarking mainly. And for that we are using a logo or simple pattern which is used for embedding. Other techniques include spatial domain watermarking and transom domain watermarking techniques. In the case of spatial domain watermarking, we are simply changing the pixel values, and on that position we are embedding the watermark bits. The image will still look similar to that of the host image even after embedding, and it's an effective transparent embedding technique. And major example of this spatial domain technique is that least significant bit method, LS or LSB method. In the case of transom domain watermarking, as the name suggests, it may transform the image into certain coefficients, and these coefficients can be in the form of Fourier transformation, after Fourier transformation, or after cosine transformation, or even after Wavelet transformation. And this embedding is done on those transformed coefficients, not just directly onto the pixels. And this transform domain watermarking techniques may prove the properties of watermarking, that is both invisibility and robustness, better as compared to that of the spatial domain watermarking. So major applications of watermarking include, it serves as an authentication tool, and also mainly used for detecting the positions where certain kind of tampering occurred or not. And also the major application is for assessing the quality. So moving on to the summary of related works, we have analyzed that came to the conclusion that spatial domain approaches shows less performance, or it is found to be more complex in the case of, or not complex, but it is found to be inconvenient to do certain kind of embedding or extraction with the spatial domain technique as such, but we need to concentrate more on the transform domain watermarks, which is DFT or DCT. But even though if you are using Fourier transformation or cosine transformation, it can cause certain blocking artifacts, and these attacks must not be robust against certain kind of geometric or non-geometric attacks, which I have already mentioned, and it is not at all ideal for the human visual system. The HVS characteristics, or the human visual system characteristics, says that, or HVS masking says that, human eye is less sensitive to the areas of high frequency subbands, that is HH, HL and LH, or the areas of image where brightness is high, or those highly textured areas, or the areas near to the edges. So embedding is done mainly on the high frequency areas, that is HH, HL and LH areas, and it is least done on those areas of LL. So we must need a system which is more imperceptible and secure or robust against certain kind of attacks, and also need to be less complex in the case of computational cases also. So we are using discrete wavelet transform for the proposed system. So an efficient watermarking scheme must be robust, secure and imperceptible. The main objective of the proposed system is that it introduces an invisible grayscale logo watermarking algorithm, and that logo is not as such embedded into the host image. It is being transformed using Arnold transformation, or certain kind of texturization is being done on the logo image, and finally it attains the properties of imperceptibility and security. This is the basic diagram showing different stages of the proposed system. Initially we have the host image and the logo image. Initially we have classified the host image into certain blocks, and then logo image is not embedded initially, but it is being transformed through Arnold transformation, and then it is being embedded into those host blocks, and this embedding is done based on discrete wavelet transform. Finally we will be obtaining watermarked image. Main modules of the system include texture segmentation, which is based on some keys, and logo scrambling is done using Arnold transformation. Then embedding and extraction is done in DWT domain. Initially the host image and the logo image is uploaded. Here you can see Barbara image, and that is the host image of size 512 by 512, and the logo image is of size 64 by 64. Initially a key is being entered by the user, and the key can be of any type, and host image is initially being classified into 64 or segmented into 64 cells or blocks, and all those blocks are not at all used for the purpose of embedding. Only the blocks which is having even locations is used for the purpose of embedding. So the locations of the positions is being randomly generated, and all those even locations which is shown as white textured in the presentation, and all those black textured regions shows that they are the odd locations. We are not so performing any kind of embedding on those black textured regions. Embedding is done completely on the white textured region. In the desegmented figure, you can see that the host image is being segmented initially. It is being segmented initially into certain blocks. 64 by 64 cells are being segmented, and after performing the texturization, it is desegmented, and the desegmented figure is shown here. Then the next stage is logo scrambling. The scrambling of the logo is done based on Arnold transformation, which is a two-dimensional transformation, and can generate the scrambled images. The transform is done based on the following equation: x bar equals to a1x plus a2y plus kl mod l, and y bar equal to a3x plus a4y plus kl mod l. Here initially we have the location or the pixel for the logo image as x, y, and after transformation it is being changed to x bar and y bar. The new locations are calculated based on this following equation. These are the basic conditions that the parameters a1, a2, a3, a4 and k must satisfy. In this Arnold transformation, it includes both rotation and iteration. The iteration number can be given randomly or can be assigned to any number. Here you can see the pepper image, which is being transformed using Arnold transformation, and finally we will be getting the exact pepper logo image as such. This shows the periodicity property of Arnold transformation. That is, initially we have the pepper image, and after all those transformation we will get back the same logo image. So we need to concentrate on the dissimilarity estimate. That is, the host image and the obtained watermarked image need to be similar. So we need to find out the dissimilarity estimate, and we need to minimize the dissimilarity. For that purpose, we are using HOG feature, that is histogram oriented gradients. So that is being computed based on the following equation, and that computes the differences between the histogram oriented features of host block and also the transformed logo. Here the Arnold transformation and rotation is being applied to minimize the dissimilarity, which means that minimum dissimilarity obtains maximum imperceptibility. So embedding is done mainly based on DWT, and for that purpose as inputs we can have the host blocks and also the scrambled logos. And here also HBS based embedding is employed, which I have already mentioned. Here you can see the bands LL, HL, LH and HH bands. Here we are using HBS based embedding. So watermark embedding is mostly done on those areas of HL, LH and HH. The embedding equations are shown here. So in the case of LL subband, the weight of alpha k controls the strength of the embedding for the kth block. A lesser relative weight of 0.2 alpha k is used for the LL subband due to the HBS increased sensitivity to this lower frequency range. So finally we will be obtaining the watermarked image. In the case of watermarked extraction, we will be using the similar steps which we have already used in embedding, and initially after subtracting all those bands, initially we will be getting the scrambled logo. Then we need to descramble that logo using inverse Arnold transformation. Then we will be obtaining all those extracted logos. We need to average all those logos, and finally we will be getting the final logo. Moving on to the experimental analysis, we proved the invisibility property and also the security property. That is, the watermark is completely invisible or this host image and also this watermarked image need to be completely similar. And in the case of security, if you are entering the similar key, then the best recovered image, or we will be getting the best recovered image. In the case of analysis part, initially we are entering the same key, then we are obtaining the PSNR value of range about 36 or 38. And if you are entering the different key, that means if we need to enter the same key in the extraction purpose also, in the extraction procedure also, which we have already entered in the embedding phase. So finally, if you are entering the different key, we will be obtaining the less PSNR value, or the quality of the recovered image will be less in the case of if you are entering with the similar keys. So we also measured the robustness of the scheme using noise called salt and pepper noise, and PSNR itself is used as a metric. And here also the original logo is compared with the recovered logo, and certain kind of distortion occurred in the case of watermark and logo images, and that is being analyzed. Here you can see the distorted watermark image and the recovered image. So in the case of salt and pepper noise, the PSNR value will be of range 38 point something, and if you are not at all having any kind of noise, its PSNR value will be around 49. So PSNR value here, it is used to detect the quality of the recovered image. So moving on to the future works, this system is completely be employed using discrete wavelet transform. So we need to ensure more robustness against various attacks or geometric and non-geometric attacks. We need to bring out some system which is going to be less complex in case of computation. So better wavelet transformation also can be employed, but with this DWT itself, we can employ certain kind of transformations other than Arnold transformation that can be done based on dynamic mapping, which is based on certain logistic scrambling or dynamically generating scrambled images that can ensure more security. And I have mentioned in order to use the least complex system, we can employ certain kind of integer wavelet transformation nodes. And also we can focus on color images, and the system is only focused on the grayscale images. So moving on to the conclusion, the system has introduced an invisible logo watermark, grayscale logo watermarking algorithm, and which is initially done based on keys, and based on that the host image is being textured, and also the logo image is scrambled using Arnold transformation. And also the quality of the watermarked images and the recovered images is being done using PSNR estimation. And also in the case of quality estimation, as a future work, I can include certain kind of noises also, and with that noise or with that attacks, we can analyze the system effectively. These are the references which I have used. Please get back with the queries. Thank you.